Hello everyone, I am Dr. P.S.V.Shanmukhi, Associate Professor, Department of Physics, Aditya University. Now I am going to explain about the Zener diode mechanism and the VA characteristics. At the end of this lecture, the student will able to understand the construction of a Zener diode and he can also understand the VA characteristics of the Zener diode. Coming to the Zener diode. So, what is a Zener diode? How it is different from the ordinary diode? A Zener diode is actually heavily doped p-n junction diode which works under reverse bias. It is designated to operate reliably in the reverse breakdown region to provide stable reference voltages or voltage regulation that is actually typically between 2.4 volts to nearly 200 volts also. So, unlike the standard diodes, it allows current to flow in the reverse voltage or reverse bias case and reach a specific Zener voltage and maintaining a nearly constant voltage across its terminals. Actually, we want to maintain a constant voltage in the circuit, we generally prefer a Zener diode. So, at the breakdown voltage, generally it becomes constant voltage even though the current reaches to infinity. So, once again, Zener diode means it is heavily doped p-n junction diode. It operates or it works under reverse bias. Under forward bias, it works as just like an ordinary p-n junction diode. Anyhow, this is the circuit symbol for the Zener diode. So, ordinary diode, whereas ordinary diode we just draw like this P type and N type semiconductors. Here also P region and N regions are there and a little bit Z type thing is given there. Anyhow, this is the circuit symbol for a Zener diode. So, whenever it is means heavily doped, what happens? Suppose this is a p-n junction diode, P type semiconductor and N type semiconductor, and it is the depletion layer. When P type semiconductor is heavily doped and N type semiconductor is also heavily doped, what happens? So, under this condition, the depletion layer width becomes very much narrow. The depletion layer, this becomes very much narrow. Of course, when unbiased case, just like an ordinary p-n junction diode, it also does not conduct any current. Under forward bias, what happens? When this is connected to a forward bias, positive terminal is connected to P side, negative terminal is connected to N side. As usual, the holes are the majority carriers in this one, electrons are the majority carriers in N region, and the holes are pushed into the next region, electrons are pushed into P side. As a result, the current flows. That means, under forward bias, it works just like an ordinary p-n junction diode. Suppose when you increase the voltage from 0.1, 0.2, 0.3 etc., the forward voltage is taken on the x-axis, the forward current is taken on the y-axis. So, the current is gradually increasing and it becomes infinity after a certain voltage. Simply one thing, it is 0.3 to 0.7, the barrier voltage. That means, the forward bias, the depletion layer is nearly 0.3 to 0.7. When you increase the voltage up to a certain voltage, no current flows, the barrier width gradually decreases. At a certain voltage, the barrier vanishes. That's why suddenly the current goes to infinity. So, this is showing the forward characteristics or forward VA characteristics. Okay, under reverse bias, what happens? So, under the reverse bias condition, observe this is a p-n junction diode, P type, N type semiconductors are there. As usual, the negative terminal is connected to P side, positive terminal is connected to N side. So, what happens? So, because of here, the holes are the majority carriers, in the N side, electrons are the majority carriers. So, when you increase the reverse voltage, what happens? Actually, the barrier voltage, these two are acting in the same direction. As we are increasing the reverse voltage, the depletion layer width is increasing, the barrier width is increasing. As a result, So up to a certain voltage we don't find any current in this one, but generally a minority carriers are also there. In p side electrons are 1 or 2 minority carriers are there, n side 1 or 2 minority carriers holes are also there. Under reverse bias they may conduct some current, a leakage current is there little bit, and up to a certain thing it happens like that. Suddenly at high voltage what happens, the junction breaks. We are applying the reverse voltage, the barrier width is gradually increasing, but as there is no elastic property, the junction breaks at a certain voltage. That's why what happens, suddenly infinite current flows across the junction. That means even though the current is increasing to infinity, the voltage remains constant. That's why this can be used as a voltage regulator, voltage stabilization. So we are using it as voltage stabilization. So to get a particular voltage in a circuit, we use this one. These are the VI characteristics of the Zener diode. Once again coming to the Zener diode. Zener diode is heavy lead doped PN junction diode. It works under reverse bias especially, and under forward bias it works as a normal PN junction diode. Actually due to heavily doped condition means the holes, more number of holes we find in P side, more number of electrons we find in N side. As a result the depletion layer width becomes very much narrow. Under forward bias means coming to VI characteristics, as we are increasing the forward voltage, the forward current initially it becomes 0 up to a certain voltage, afterwards little bit increases, afterwards it increases to infinity suddenly, drastically. Why? Because at this voltage the junction becomes 0. As we are applying the forward voltage, the barrier voltage becomes means it reduces, or the barrier width gradually decreases at a certain voltage. So the barrier becomes 0, no barrier, suddenly infinite current flows. Whereas in the reverse bias, when you increase the reverse voltage, negative terminal is connected to P side, positive terminal is connected to N side. Under this reverse bias, initially no current flows, or due to minority leakage current may be there, and afterwards at a certain voltage, as there is no elastic property, the junction breaks, and as a result suddenly infinite current flows across the junction. So this is used as a voltage stabilizer, means even though the current goes to infinity, voltage becomes constant. This is the VI characteristics of the Zener diode. So in this article we have discussed the construction. Coming to summary, we have discussed the construction of the Zener diode, how a Zener diode is designed, how it is different from an ordinary PN junction diode. We have seen that one, and also we discussed the VI characteristics of the Zener diode. So what are the characteristics under forward bias, under reverse bias, what is the Zener breakdown, all those things we have seen in this article. Okay, thank you very much.